Hello together, welcome to the second part of diagnostic possibilities at our Ethernet IP API node. In the first video we had covered the web server and the explicit messaging instructions. Now we have a focus on status and diagnostic assembly, the diagnostic add-on instruction and the L5X import diagnostic information. The status and diagnostic assembly we start right now, and therefore we go to our project and have a closer look what is the status and diagnostic assembly. If you go here to the node, we see everything is running, and I'm going now here offline and go here to the change. And here in the change, I'm defining the connections. And you see here, I have the possibility with the API system and Ethernet IP to have different connections. And the status and diagnostic assembly is the instance 129. Here, if I'm going down, you see here diagnostic data. This is the assembly instance 129. If I'm using this in my project, I'm getting all the information in a second connection in my tags. To have more details concerning this, I recommend that you are going again to the support portal and you have a closer look on the application node here. In this application node, you're finding all the information concerning assembly instance 129. Here you see if I'm scrolling down to chapter 4, then everything here is explained concerning 129 and what is the meaning of the global diagnosis state, count of current active diagnosis, and so on. That's the reason why I strongly recommend to have a closer look here. Going back to the system, you see here from our EDS file, the diagnostic assembly is allocating just 24 bytes. I can of course change here to int, dint or real if I want, but for the video I'm using just the SINT format, and I have now to take care about the 24 bytes because this is from my EDS, but the reality is looking way different. And to check the reality, I'm going to the web server. And here you see the web server. And you see here in the assembly view, which you are finding always here at the Ethernet IP tab, the possibility to check all the possible assembly instances of our system. And the 129 diagnosis and status is allocating now at this system 96 byte. And my system includes at the moment the 7 modules, and the 96 bytes are calculated automatically and available here in the assembly view for you. You see here the same information what we have seen in the application node, and for my configuration, now just the 96 bytes are important. Going back, say here 96 bytes, say OK, say yes, and then say download. So this takes around 30 seconds, I would say, and then everything is running with 2 connections, one for the process data exchange and one with the information concerning the diagnostic assembly. Now you see everything is running, and if I'm going now to my controller tags and scrolling down, then I find here my API node. And the API node contains now all the 96 bytes what we have seen in the web server. And if I'm now provoking, for example, an error, then you will see here in the monitor text the values. And these values are belonging to the assembly instance 129, which is described here again in the application node in detail. And of course, you can go also to the web server and then you find also this information. And you see here, for example, the latest diagnosis code is located at 64 offset. It means with send format at tag 8. Tag 8 starts here. This is tag 8, and this information of code is always 4 byte long, and at the moment we have 6112. We can change this here to the hex view. And if we go now to our manual, then we are recognizing, okay, the error what is at the moment active is switch off load supply. The 2 is here, the 1 is here, this one is here, and the 6 is here. This is now available in our tags. The only disadvantage what you are seeing here is we have no description. We have to build up the relation. We have also to take in account which tag is what meaning. Therefore, I can use very easily the assembly view in the web server, or I'm doing this by scratch with the help of the application node. Okay, that was now status diagnostic assembly. This is done. Now we are going to the diagnostic add-on instruction. The diagnostic add-on instruction you find in the support portal. If we are going to the support portal again, then we are seeing here the new API module parameterization in Allen Bradley. And this is an application node which is including a lot of add-on instructions. I'm just saving the application node somewhere where I find it, make it here, maybe to the desktop. And if I'm going now to my desktop, then I'm seeing here the application node. And if I would unzip it and open it, then I see here the add-on instruction. And at the moment we have here three add-on instructions: the diagnostic, the ionic parameterization, and the parameter add-on instruction. And for my project, we are using the diagnostic. I have done this already. That's the reason why I now go here in the project, go offline, and say here at the add-on instruction, import add-on instruction. Import add-on instruction and to the location where this diagnostic is. Just click on it, and now the system is importing the add-on instruction. I press here OK. Now the system is creating the add-on instruction, and I can use it in my programming code. You see here, this is the add-on instruction. We also have UDTs with the information of the data, global diagnosis date, count of current active diagnosis, and here the module state information, module number, submodule number, channel, and so on. Going now to my main routine, I have now here to create a new run, and then I just drag and drop the add-on instruction to this. The first thing what I have to do is I have to define the instance of the add-on instruction. I say here it's the diag, and right mouse, new diag. It's the instance I created. Then I have to define the first element. And this is very important to know. This add-on instruction works only if you are using assembly instance 129. If you don't use this in your EDS, generic or Festo EDS, then the add-on instruction is not working. I have integrated this assembly instance already, and I have now to take the first element. Going here and looking for my API. And you see here, this is my API. This is the status, what we have created before. And if I scroll down, then the first element is this one here. This is what we have to use for the add-on instruction. Make a double click on it, make enter, finished. Then we have here also a IO global diagnostic. This is a tag where we the information copy what we are getting from the add-on instruction. Therefore, I just say here global diagnostic, right mouse, new global diagnostic. The last thing what we have to do is here to define the message, because this add-on instruction is using in the background an explicit messaging routine. Therefore, I'm going here and say read MSG. This is my message. I say here right mouse, new read MSG, create. And now I have to define the parameters. Therefore, I'm clicking just here on the three dots and I get here to the pop-up where I'm saying here get attribute single. The class is 10, the instance is 0, the attribute is 2. And the destination element, this is very important, is now diag, scrolling down, destination value. This is the destination element which you have to take for this add-on instruction. Please take this, otherwise you have strange behaviors maybe. This is recommended. It is also here informed inside the description which you are getting with the download. There everything is also explained. See it here. This is the add-on instruction. Everything here is inside explained how to use it. The next thing is to define the communication path. The communication path is here. Browse my API node. And now we are finished with the add-on instruction and we can start the download. So now everything is running. We have no errors. I am now just enabling the system, but before I go back here to the live screen and scroll here a little bit down that you are seeing my block. So, and you see I have an active error at the moment. And if I'm now here enable everything, then I'm getting after a few seconds all the information of the block. Here's the latest diagnosis code. I have here active diagnosis 5, active module 7. You see here everything is done. If I'm provoking a short circuit, then I'm getting the short circuit information, and we have now 6 active diagnoses and so on. The block self is working. If I'm deactivating the errors, then we have, of course, no error anymore. And this is how the block is working, and you're getting everything inside the add-on instruction and the corresponding tags. You see here the global diagnostic tag. If you have a closer look on this, then you find all the information also in this global diagnosis tag. If I'm scrolling here down, here is the global diagnosis tag, and here again provoking an error. Then you are getting the information, and this is how this add-on instruction is working. Not so complicated. And now we are going up to the next topic. The next topic is import diagnostic information. We have in a previous video shown how to make the L5X import. And if you're doing the L5X import with the diagnostics, then you have, in my opinion, the most advantages, because then you have everything in written text inside your project. And you don't need the status diagnostic assembly way. The diagnostic add-on instruction is also may not necessary, and also explicit messaging is not mandatory. Here in my actual project, I have created here this second module via the L5X export, and at the moment it is in a Hibit. And to use now the features of this export, I am now going here offline and say here to this API module, you are now the address 6, or no, the address 10, say here apply. Go here to the connection, say you are an Hibit, apply, and say here, okay. Then I'm going to my Ethernet module where everything was done already via the L5X export. Say here it is 5. Say here apply, and it is not inhibit anymore. Say again, okay, okay. And then I'm downloading here the project again. And after again a few seconds, I can go to the run mode. Okay, now we're in run mode, and you see here everything is running, no issues. And if I go now to the controller text, then we are finding here, if we are going to the controller text, then we are finding here now this interesting my first project status based on our L5X export. And what you're seeing here, you're finding all the information with description here on the right side, directly in the text, global status, here again to the right side, what kind of error the bool are meaning. This is all based on the description inside the application node. And if I'm provoking here now an error, then I'm getting exactly the information with the description. If I can go a little bit back or down in this case, and here you see again, provoking again an error. Then I'm having everything here available. I can also make here under voltage, then it is also working. This is the big advantage if you can use the L5X export, and with the diagnostic assembly, what you can decide by the export, you are getting everything in clear text, and you have not to take care where is the mapping, and the only thing is just what is the meaning. Check the meaning, but here with the clear text on the right side, I think it's very easily. And for me, this L5X export is the easiest way to get everything inside the PSC project. Thanks for your attention.